Okay, good morning, class. So at this point we're busy with trigonometry. It's our second lesson. You had no homework on trigonometry, right? We mentioned the next thing we're going to look at, which is naming of triangles, I think it was. This is a note we're going to read through. Naming of triangles. You don't have to write this down. Now coming from, first get the page number 103. Okay, so on page 103 we are told naming of sides of a triangle. Instead of naming the sides of a triangle using the two letters at each end, we often use the lowercase letters corresponding to the letters used for the vertex opposite each side to name the sides of the triangle. Now we have done that before in Pythagoras. You remember? You were busy with a triangle, and that was your 90, and this was PQR, or ABC, make it ABC. Then CB would also be lowercase a. You guys remember that? Pythagoras we use that, not so. CA is also lowercase b, and AB is lowercase c. So let's just standardize that figure. Okay, instead of using the vertex letters there, we can go with the lowercase values. Okay, you guys understand? So now looking at example here. In triangle PQR, use the letter P, lowercase p, to indicate QR. You see here? They will use P, and the lowercase letter is always opposite that vertex angle. So that is vertex P, or angle P, this is lowercase p. Can you see that, people? This is R, that's lowercase r. That is Q, lowercase q. Alright, you guys understand? It's very simple, no? In triangle ABC, use lowercase b to indicate side AC, lowercase a for CB, and lowercase c for AB. That is straightforward. No? Any confusion here? So now we're going to look at the definitions of trigonometric ratios. Write that down there. So your next subheading. Definitions of trigonometric ratios. Have you written the definition already for trigonometry? No? So write this down. We are told trigonometry is based on the concept of similar triangles. Okay? We're not triangles similar. If all the angles are equal, then the triangles are similar. The trigonometry is based on the concept of similar triangles. Triangle ABC, PQR and XYZ are similar because the angles are equal and the corresponding sides are in proportion. Okay, so you write that down. Let's finish. Oh, okay. And I want you guys to draw the following triangles. These are the triangles we spoke about yesterday. Not so? To draw a rough sketch of that quickly. Okay, you guys got it? Okay, this is on page 104. So these are the triangles we dealt with yesterday already. Let's see what they giving us the note on now. So what they want you to look at is the fact that, can you all see these ratios here? Can you all see from here sitting? To make it a bit bigger. So yesterday we worked out the sides of this triangle, not so. Now these triangles. So we had 5 4 and we worked out 3, not so. We had 8 and 10 and we worked out 6 and we worked out 9. Okay? But how did we work that out? By using the Theorem of Pythagoras, not so?
Yes, sir.
Alright. So what they bring our attention to now is the fact that BC, you see this length here? BC, let's go with it for now. BC over AC is 3 over 5, not so. So what is QR over PR? 6 over 9, which is 3 over 5. Can you see that, people? What is ZY over XZ? 9 over 15, which is 3 over 5. What do you notice here? All of that are equal. Not so? Let's look at this one. Let's look at this one. What is AB over AC? 4 over 5. What is PQ over RP? Which is 4 over 5. What is XY over ZX? 12 over 15. 4 over 5. You see, all of that is not equal. Not so? Do one more. What is BC over AB? 3 over 4. What is RQ over PQ? 6 over 8, 3 over 4. What is ZY over XY? Which is 3 over 4. That is again all the same. And what did we say? Trigonometry is the, what's trigonometry? What? They are based on concepts of similar triangles. These triangles are similar. So there's some relationship that of course that's existing between these sides. We go on further, we are told that sides BC, QR and XY are all opposite theta. Take note of that now. Okay? You see this angle theta here? Opposite to theta is that angle. Can you see that? Let's bring this in here. Okay? We are told that note, the ratio indicates the constant for a particular angle theta and each ratio has a name. This is based on the position of the sides in relation to the angle. So it's always to do with the relation to the angle. So if we look at this here, this is opposite to the angle, not so? This angle, this side here is opposite to the angle. That is opposite to the angle. Not so? We're going to call opposite for now O. You guys got it? Natali, you alright? What's wrong? Sorry? Headache? Want some water? Huh? People, to the angle, this is what is next to the angle, not so? And we'll call that the adjacent side. What do you notice here? Adjacent side. This here? The adjacent side. Not so? Here's 90. So this is what? Hypotenuse. Hypotenuse. Not so? So if we look at the first one we looked at, BC over AC. In other words, this is what? Opposite over hypotenuse. There's going to be O over H. Not so? If you're looking at QR over PR, O over H. ZY over XZ, O over H. Can you see all of that? Gives me O over H. Okay? Did I lose anybody yet? So let's look at the next one. It's AB over AC. AB over AC. What is that? A over H. PQ. Sorry, PQ over RQ. RP, sorry. A over H. XY over YZ. X, sorry. A over H. So all of that gives me A over H. You all okay with that? Yes. What will the next one be? BC over AC, BC over AB over A. All of that is going to be A O over A. Not so? Right. The hypotenuse H, the adjacent is A, the adjacent side to the angle theta is A, it's next to the angle, and your opposite to the angle is theta. That is really what they say now. Now we are told, we spoke about that, the ratio opposite over hypotenuse, O over H, is called sine. Okay? We'll be giving it now mathematical notations for O over H, A over H, and O over A. This is only for what type of triangles? Right angle triangles. There has to be, the condition for using the sine, it has to be a right angle triangle. Likewise, when you're using Pythagoras, Pythagoras can only be applied in right angle triangles. Not so? Likewise, this here can only be applied in right angle triangles. So O over H will always be known as sine. Okay? We say sine. People, sine itself means nothing. Sine is a sin, you know. Sine means nothing without the angle. So you must put the angle. So sine of theta will always be opposite over hypotenuse. In any right angle triangle, for that angle itself in that position, sine will be its opposite over hypotenuse. Okay? It will always be opposite over hypotenuse. Let's read on what they say. Sides AB, PQ, XY are all adjacent next to the angle theta. Sides AC, PR, XZ are all the hypotenuse of the triangle. Are opposite the right angle. The hypotenuse is always opposite the right angle. The ratio adjacent over hypotenuse, or A over H, is called cosine. Okay? Cosine. And cosine of theta, the abbreviation is called cos. Got cos there? Okay, you guys understand? And then, lastly, we are told that the sides AB, PQ, XY are all adjacent or next to the angle. Sides AC, PR, and XZ are all the... Now we read that one already. The next one. Sides BC and QR and YZ are all opposite the theta angle. sides A, B, P, Q, and X, Y are all the adjacent sides to the angle theta. The ratio A over O, or O over A, is called the tangent to theta. And it's called, or abbreviated as, tan of theta. Okay. So this is what we call our trig ratios. Write that down. Those are your trig ratios now. Okay. Okay. Now, some you need to make a note of. Write this neatly. That is theta. This is your opposite. To the angle, this is your adjacent, is next to the angle. And this will always be your hypotenuse, will always be opposite the 90 degrees. Okay. Now, if you look at your calculator, okay, you see here, on the calculator, here you got the trig ratios. Can you see that? You got sine, cos, and tan. Can you see that on your calculators? Whose calculator don't have that there? You all have scientific calculators, no? So in that order, which is sine, cosine, and tangent. Sine, cos, and tan means nothing without the angle. Not so. In that order, we're going to say Oliver has a hat of apples. Okay. So sine will always be opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Which is, what's that? What's the name I told you now? Is that right? Oliver has a hat of apples. Whatever you want to remember with that. So katawa, even dirty rhymes you guys come up with. It's fine. As long as you memorize it. Okay. Again, that's your trig ratios. So your homework is going to be exercise 5.2. You do for me number 1 for homework, okay? Exercise 5.2, number 1. Number 2, we're going to do now number 3, 5, and 7 on the board now. Okay. The rest of it is homework. Alright, the rest of the exercise. When I say 3, I'm going to do 3 or 2.